بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the final exam of term 211 of Stat 101. Let us solve it together. First part, answer the following 10 multiple choice questions by selecting the correct answer. What is the area under the normal curve less than z equals -1? So he needs the probability that z is less than -1. Well, you can find this from the table of z. The table of z is given at the end of the exam. Notice that the table gives you the area from 0 to z, and we cannot find z is all positive numbers here. So to find the area, the probability that z is less than -1, I cannot find it directly from the table. But the area to the left of -1 is equal to the area to the right of 1. And to find this area, I can find this area from the table. So the table will give me the area between 0 and 1, or the probability that z is between 0 and 1. You can find this area by looking at z equals to 1. So here is 1, and that's the area 0.3413. Okay, this is the area between 0 and 1. But I need, so the area between 0 and 1 is 0.3413. So to find this area, the probability that z is greater than 1, or the probability that z is less than -1, both are the same, would be equal to 0.5, because the area to the right of 0 is 0.5 minus this area, and the answer would be negative. There is no negative, sorry, 0.1587. And that's part C. This is a multiple choice question, so you can also use the calculator, okay? If you go to mode stat, press mode 3, that's stat mode, and then press 1, okay? And then on, get out. So mode 3 stat, then press 1, variation, and then on, or AC. And now press shift stat, okay? And when you press shift stat, you will find number 5, distributions. If you press number 5, you have 1P, 2Q, 3R. I need here to find the probability that z is less than -1. I can find this by using number 1 in the calculator. So I write P and I write just -1. So I choose number 1. I will see P. So I write inside it -1 and say equal, and the answer would be in the calculator 0.15866, which is, when you approximate to 4 decimals, 6, it would be 0.1587. The second question, the mean of a normally distributed group, so mean is $10,000, and the standard deviation is $100. What is the z-score for the income of 1,100? Well, the z-score is defined by x minus mu over sigma. So x is 1,100 minus, this is not 10,000, this is 1,000 mu. minus 1000, again 3 zeros, over sigma, which is 100. I'll have 100 over 100, which is 1. So the answer of part 2 is A. On a very cold winter day, 5% of students at Prince Sultan University are absent from classes. If 10 students are randomly selected, what is the probability that at most one is absent? Okay, assume that we have binomial process. Okay, since it is a binomial distribution, so now on a very cold winter day, 5% of students, so this is P 5% or 0.05, 5 over 100, okay? If 10 students are randomly selected, so this is N, small n, what is the probability that at most one, so X is, at most one means less than or equal to 1. So at most one is the maximum. So this is equal to probability of 0 plus probability of 1. And you can use the binomial distribution formula. Well, instead of finding both of them, I will use the summation here. So I will say summation from 0 to 1. And the definition of the binomial distribution here, NCX. So I will use this notation. N here is 10, and this is X. X could be 0, and then it could be 1, times P, which is 0.05 to the power of X, times Q, which is 1 minus 0.05. So it's 0.95 to the power 10 minus X. And you can use the calculator to evaluate this sum, even if the question is less than or equal to 5 or 4 or 6. So instead of adding, using the formula and adding 3, 4, 5, 6 terms, you can use this method. You must be, and you must get out of the stat mode and be in the usual mode, mode 1, and then above log you will find summation. So you press shift log, you get the summation, and you write 10, and now you go to NCR, which is above the division. So shift division, throat C, and then alpha X. Okay, this is 10CX. And then you multiply times 0.05 to the power and shift and alpha X, and then times and 0.95 to the power 10 minus alpha X. And then you go to the right with the cursor, it brings you down. So you write X from 0 to 1, and you ask for the answer. And the answer would be 0.91386 or 39, and that's part D. If you want to use the formula directly, then probability of 0 plus probability of 1 would be 10 0 0.05 to the power 0, 0.95 to the power 10 plus 10 1, 0.05 to the power 1, 0.95 to the power 10 minus 1, which is 9, and you will get the same answer. In a large metropolitan area, past records revealed that 30% of the high school graduates go to college. So 30% go to college. From 20 graduates selected at random, use the binomial. So again, here we are using the binomial distribution. So 30% is P, and 20 graduates, that's N. To determine the probability that exactly 8, we are asking about 8 will go to college. So NCX 20C8 times 0.3, which is P to the power 8X, times q, which is 1 minus 0.3, which is 0.7, to the power 20 minus 8, which is 12. And if you use your calculator to evaluate this, you will find the answer 0.1144 when approximated to 4 decimal 4 decimal places. There are 10 rolls of film in a box and 3 are defective. So 3 of them are defective. 2 rolls are to be selected without replacement. Without replacement, we do not put the first roll back. What is the probability of selecting a defective roll followed by another defective roll? So the probability of selecting the first roll to be defective, we have 3 defectives. So 3 over the total number of rolls, which is 10. So this is the probability of selecting a first a defective roll times followed by, so we multiply another defective. Now the experiment is without replacement, so the number of balls instead of 10, now we have 9 rolls. And the number of defectives, we have 3 originally, but we selected one of them in the first roll, so we still have 2 in the second roll. So this is in fact a conditional probability. So you can say that this is the probability of defective times probability of defective given defective, okay, if you like. So the probability is 6 over 90, or when you put it in the calculator, it's equal to 0.0667. So that's the answer. A random sample of 85 employees revealed that an employee spends an average 6.5 years on the job before being promoted. The population standard deviation. Okay, so this is the population standard deviation, 1.7. Using the 0.95 degree of confidence, what is the confidence interval for the population mean? So we need to find the confidence interval for the population mean. The formula is x bar plus or minus z times sigma over square root of n if sigma is known. So a random sample of 85 employees, this is n, okay, revealed that spends an average of 6.5. So this is the average of the sample. So this is x bar. The population standard deviation is given. So when we use 0.95 degree of confidence, we can find z either from the z table, or it's easier to find it from the t table. Here the t table is given, and this is the 95% confidence level. If you go down in this column at the end, the last number is 1.96. This is the z value. So z here is 1.96. So x bar is 6.5 plus or minus 1.96 times sigma, which is 1.7 over square root of 85. This will give you an interval. If you evaluate 1.96 times 1.7 over square root of 85, this is 0.36. So 6.5 minus 0.36 is 6.14. And 6.5 plus 0.36 is 6.68. So the answer is part C. Question 7, the weight the weight of cans of fruit is normally distributed. So we have a normal distribution with a mean of 1000. So this is the mean, mu, not sigma. And standard deviation of 50. What percent of the cans weight 860 grams or less? Notice that the weights are normally distributed. So if we call the weights x, so we need to find the probability that x is less than or equal to 860. This is a normal distribution. So it follows a normal distribution. So we can change x to z, and we change it to z by subtracting 860 minus the mean and dividing by sigma. That's the z score, x minus mu over sigma. And this will be probability of z less than or equal to, if you divide 860 minus 1000 by 50, the answer is negative 2.8. And you need to find the probability of negative z less than negative 2.8. And we have seen that you can find it either from the table of z. If this is 2.8, this value you can find from the table. So the probability would be 0.5 minus and finding 2.8 from the table. So the value at 2.8, this is 2.8. So this is the value or the probability between 0 and 2.8, 4974. Now, if you find the difference, it is 2.6 times 10 to the power negative 3 in the calculator. If you press shift eng twice, you get the answer 0.0026. Or you can just take the decimal, this decimal point, take it 3 digits to the left. So you add 2 zeros. So the answer is C. And also I told you, you can go to stat mode using the calculator, then press 1 and then on, and then shift stat, shift 1, above 1 you have stat, and then you press 5 distributions, and you ask the calculator to give you number 1, P of negative 2.8. This will give you immediately the area to the left of negative 2.8, and the calculator will say 2.5552 times 10 to the power negative 3, which is 0.02552. If you take 4 decimals, this 5 will be 6, will be approximated to 6. So this is calculator. Okay, number 8, a statistics professor receives an average of 6 email messages per day from students. Assume the number of messages approximates a Poisson distribution. A Poisson distribution, so this is lambda, the average per segment, per one segment is 6. What is the probability that on a randomly selected day, so this is 6 emails per day, so the segment is day, and here selected day, so T, the number of segments is 1. What is the probability that on a randomly selected day, she will have 3 messages? So we need to find probability of 3. Well, the formula says that probability of X equals to lambda t to the power of x, then e to the power negative lambda t, then over x factorial. So lambda t here is 6, and we need to find probability of 3, so x is 3. So 6 to the power 3, then e to the power negative 6 over 3 factorial. And if you use the calculator, you will find that the answer here is 0.0892. So the answer is part D. The Ministry of Education reported that for the past 7 years, we have these numbers of people received bachelor's degrees in computer and information sciences. What is the annual arithmetic mean? Arithmetic mean is X bar. Annual because these numbers are in the past 7 years. So every year. So it's an annually mean. So he's asking about X bar. The annual arithmetic mean number of degrees awarded. So to find X bar, you just add 433 plus 552. You add all the numbers up to 521, and you divide by 7 because they are 7 numbers. And if you do that, if you use the calculator, you will find that the answer is about 8 to 7. It would be 8 to 6 point something, 0.7. So it would be 8 to 7. The weights in grams of the contents of several small bottles are these. What is the sample variance? Well, you can use the calculator easily here to find the sample variance. If you go to mode stat 3, press 3, then press 1, and then write these numbers: 4, 2, 5, 4, 5, 2, and 6. Okay, that's it. Press on, and then go to shift stat, shift 1, it will give you shift stat, and then press number 4, variance. And he is asking about sample variance. This is number 4, SX. Well, the calculator will give you SX, okay? And SX is equal to 1.5275. So you raise it to the power 2 because I need the sample variance. And when you square it, you just press x square. It will square it, and you will find that the answer is 2.333. So that's D. Now, the second part of questions, answer the following 20 questions. Show your work in the space provided below each question, 3 points for each completed correct answer, and partial points for acceptable attempts. Data below show the marks of 7 students in stat exam. What is the 85th percentile? Well, to find the 85th percentile, I need first to arrange the numbers. So 3, 3, then 4, then 5, then 6, 7, and then 9. And to find the 85th percentile, I need to find its position. And the position is denoted by I. And the formula says that I multiply P, which is 85 percentile, 85.85 you can say, or P over 100, which is 85 over 100 times N, which is the number of elements in the sample. We have 7. So when you multiply this, you get 5.95. Since the number is 5.95, so it is in the sixth position. So 1, 2, 3, 4, 5, 6. So 7 is the 80th percentile. So the 85th percentile is 7. What is the coefficient of variation? Coefficient of variation is defined to be either if you use the population symbols, you can use also the sample symbols here. The definition is sigma over mu times 100%, coefficient of variation. So you can put these numbers in the calculator, stat mode, and number 1, and put the numbers 3, 3, 4, 5, 6, 7, 9. And then press on and go to shift 1, number 4 variance. Well, press 2, this will give you X bar. X bar is 5.2857. All right. And you can go to shift stat number 1 variance, and you can ask for number 4, which is the standard deviation. And the standard deviation, you can use, if you deal with it as a population, it's okay. If you deal with it as a sample, it's okay. I think there is no problem with that. So you can either use S, because it's not understandable from the question. He did not say it's a population. So you can say it's a population or not. So if you use the symbols of or, okay, if you use SX, this is 2.147. If you use shift stat number 4 variance, and then you choose 3, which is the population, this will give you 2.05. And if you divide this sigma, now if you divide 2.05 by 5.2857, this will give you 0.388. Of course, do not forget times 100%. So it would be 38. If you approximate to 1 decimal, yeah, 0.8%. If you use this one, of course, times 100%, if you divide 2.2147 divided by 5.2857 and then multiply by 100, it will give you 41.9%. In my opinion, both are accepted because it's not mentioned whether this is a population or a sample. So both are correct. It's a sunny day. Sophia goes to a cave to purchase an ice cream. In terms of size, she has 3 choices. Okay, 3 choices of ice cream, either small, medium, or large size. And for each size, she chooses, she may choose 1 topping of chocolate chips or almond flakes. Let me call this C and call this capital A, okay? Define the sample space. Okay, first she's going, let us think Sophia is going now to the cave and she will think of to buy an ice cream. What choices does she have? Well, she can choose the size first. So if she chooses the size, she can choose a small size or medium size or large size. And if she chooses the small size, she can choose chocolate chips or almond, okay? Also for the medium size, also for the large size. So we can say that the sample space consists of SC or SA or MC, MA or LC, LA. So there are 6 choices of ice cream. College basketball team has 10 players. Okay, those 10 players, 6 of them are senior and 4 are juniors. So we have 6 seniors and 4 juniors. 3 players are randomly selected to serve as captain for the next 3 games. So we are selecting 3 players from those 10 players. What is the probability that 2 of the selected players are seniors? Okay, this is a hypergeometric distribution, and the probability would be probability of 2 seniors would be equal to C over C. I have 10 players and I need to select 3 of them. Those 10 players are divided into 6 seniors and 4 juniors. I want to select 2 seniors. So from the 6, I'm going to select 2, but I'm selecting 3. So the third one would be a junior. And you put this in the calculator and you find the answer. The answer would be half. You write 6C2 times 4C1 over 10C3. The answer is half. A simple random sample of 240 people. So this is N, the sample size, was asked if they have insurance coverage. 66 replied that they did not have coverage. So 66, this is X. This is the success in this case. 66 replied that they did not have coverage. Based on these sample data, determine the 95% confidence interval estimate for the population proportion. The population proportion is P, and from here we can find P bar, which is the sample proportion, which is 66 over 240. And this is 0.275 using the calculator. The formula here is P bar plus or minus Z times square root of P bar times 1 minus P bar over N, okay, the sample size. So we have 0.275, okay, plus or minus. Now again, this is 95%. So if you use the T table, you will find the number 1.96 times 0.275 times 1 minus 0.275, which is 0.725 over N, which is 240. And this will give you 0.275 plus or minus. If you put this in the calculator, you will have 0.0565, and then you can say that P belongs to 0.275 minus, and you will get 0.218, and then 0.275 plus this number, and this will give you 0.332. So that's the confidence interval for P. A survey of top executives revealed that 35% of them regularly read Time magazines. 35% read Time magazines. If I call Time magazines T, for example, okay, and 40% of US news magazines, so read news magazines. If I call this capital N, this event, so probability, we have probability of T is 0.4 and probability of N, okay, so T is 0.35. Probability of reading Time magazine is 0.35. The US news is 0.4. It was found also that 35% do not read Time magazine. So this is the probability that they do not read Time magazine. So this is T complement, okay? And so and is the intersection. So it was found also that 35% do not read Time magazine and do not read US News. So this is in complement. So in fact, this is the sentence. Probability of T bar and N bar in complements equals 0.35. The question, what is the probability that a particular top executive reads either Time magazine or means union US News? So this is what we need to find. Well, actually, we know that T union N, the complement of T union N is the complement of T intersection the complement of N. So this probability is equal to probability of T union N complement. And probability of T union N is 1 minus the probability of the complement. So the answer is 0.65. So the probability of T union N is just 0.65 in this case. And there is no need, in fact, in this question of these two informations. We did not use them. We did not use them, all right? A random sample of the age of 9 patients is as follows. So these 9 ages. Assume that the population of all patients has a mean of 18. So this is mu. What is the sampling error for this sample? To find the sampling error is x bar minus mu. So sampling error equals, to find x bar, I add all of these numbers and I divide by n, and n in this case is 9. And if you add all of these numbers and divide by 9, you will find that the answer is 17. So the sample error is 17 minus 18, and it is -1. This is section 7.1. The number of traffic violations on a major road follows the Poisson distribution with an average of 4 per hour. So lambda is 4 and hour, okay, 1 segment. Now, what is the probability that 3 violations are recorded? So he wants to find probability of 3 in 30 minutes. Well, 30 minutes means half an hour. And this means that T is half. Okay, the segment here he is asking about is half an hour. So T should be half. Well, we have seen that the probability of X is what is lambda T to the power X times e to the power negative lambda T over X factorial. So probability of 3 would be lambda T here would be 4 times half, and that's 2. So we have 2 to the power X times e to the power negative lambda T, which is 2 over 3 factorial. And if you put this in the calculator, you will find that the answer is 0.18. In a management trainee program, 80% of the trainees are female. Okay, so we can say probability of females is 0.8. 20% are males, so probability of males is 0.2. 90% of the females attended college. Okay, 90% of the females attended college. So I will use tree diagram. It seems Bayes formula here. Now, any trainee could be either female or male. Probability of female is 0.8, probability of males is 0.2. Now, 90% of the females attended college. So any female, if the trainee is a female, so either she attended college or did not attend college. Probability that she attended college is 0.9, 90%, and this would be 0.1. From the males, also either he attended college or not attended college, 0.78 of the males attended college, and this one would be 0.22, 1 minus 0.78. Those did not, of the males did not attend college. What is the question? What is the probability that the person selected will attend college? So he's asking probability of C, attend college, given that the student is a female. So he's asking about probability of C given F. Well, actually, probability of C given F is this probability, 0.9. Because this is the probability that the person attended college given that she is a female. So there is no Bayes formula here. But if he asks about, so this is the answer in this case. This is the answer to the question. Okay, this is the answer. But if the question, if we need to find probability of, if he wants Bayes formula, he should ask the question as follows. What's the probability that the person is female given that she attended college? Okay. In this case, to find this probability, it is the probability of F intersection C over probability of C. And probability of F intersection C, you can find probability of F intersection C from the tree diagram by multiplying 0.8 times 0.9, 0.8 times 0.9. And then probability of C, you can find it also from the tree diagram here. This is C. So either C comes from this 0.8 times 0.9 or from here. So 0.2 times 0.78. So here we are using Bayes formula, but the question was about C given F. So that's the correct answer. Just 0.9. Okay, 20. A committee of 7 members is randomly selected from a group of 8 faculty members and 10 students. Okay, so we have 10 plus 8, we have 18, and we need to select 7 of them as in a committee. What is the probability that the committee will have 3 faculty members and 4 students? Okay, so probability, this is again a hypergeometric distribution, 3 faculty and 4 students. We have C, C, C. Total number 18. We need to choose 7 out of them. Those 18 are divided into 8 faculty members and 10 students. We are going to select 3 faculty members and 4 students. Okay, and if you put 8C3 times 10C4 over 18C7 in the calculator, you will get 245 over 663, or if you want to write it as a decimal, it's 0.3695. The mean of a normal distribution is 400 bounds. The standard deviation is 10 bounds. What is the area between 415 and the mean of 400 bounds? So he needs the area or the probability that X is between the mean, which is 400. I start with the smaller number, 415. So this is the probability that X is between 400 and 415. This will give you the area between these two numbers. I need to change these two numbers to Z using the Z score. So 400 minus 400, or immediately you can say that this is 0 because it's the mean, over 10, and this would be Z, and this would be 415 minus 400 over 10. So in fact, this is the probability that Z is between 0 and 1.5. And you can find this directly from the table because Z is between 0 and 1.5. And this is what this table gives, the areas between 0 and Z. So immediately go to 1.5, and that's 1.5. So the answer is 0.4332. So the answer is 0.4332. This is from the table. If you want to use the calculator, okay, you don't use P here, okay. You go to mode stat, 3 stat, number 1, then on, and then shift 1 stat, then 5 distributions, and now you have number 2 Q, okay. So Q in the calculator, Q will give you the area between 0 and Z, okay. So you ask for Q 1.5, and the answer would be 0.43319. And if you approximate this to 4 decimal places, this one would be 2, and you will get the same answer. What is the area under the normal curve between these two numbers? Well, this is exactly the same question, but even easier. So we need to find this. Either you go to the table and look to 1.79 directly, but to find 1.79, this is 1.7, and for 9, I go up to the last, this is the 9, so the last column, so 1.79, that's the answer, 0.4633. So the answer is 0.4633, or ask the calculator for Q of 1.79, and the calculator 5 distributions, then number 2, Q of 1.79, and the answer is 0.46327. If you approximate to 4 decimal places, you get the same answer. Given a population in which the proportion of items with a desired attribute is P. So this is the population proportion, okay? If a sample of 400, so this is N, what is the probability, the proportion of successes? So probability, proportion of successes, which is P bar in the sample. So sample proportion will be greater than 0.22, okay? Now, this is the sample proportion. We change it to Z. Of course, you can check that N times P here is greater than 5, and N times Q is greater than 5, because if you multiply 400 times 0.25, that's 100, that's of course greater than 5. So I can change it immediately to Z. And to change to Z, you remember, the formula is sigma. This is the standard error for P bar. It is P times 1 minus P over N, okay? And P is 0.25, 1 minus P is 0.75, N is 400. So sigma would be equal to, you can say point by the calculator 165. So here I'll have 0.22. The formula is to change to Z. Z equal to mu P bar is P minus, okay. We start by P bar minus mu P bar, which is B over sigma P bar, okay. You can let me write it like this, mu p bar, and this is sigma p bar, okay? So it is p bar minus mu p bar, which is p over sigma p bar. So 0.22, this is p bar minus p, which is 0.25 over the standard error, which is 0.02165. And this would be probability of z greater than, if you use the calculator and round to 2 decimal places. So it would be probability of z greater than negative 1.39. And now to find this area from the table, this is negative 1.39. And he needs the area greater than, so we need all of this, okay? So this would be 0.5, can say this is 0.5, which is the area to the right of the 0, plus the probability that z is between 0 and, of course, negative 1.39 and 0, but this is equal to the probability that z is between 0 and 1.39, okay? So it's 0.5 plus. Now, if you go to the table and search for 1.39, so this is 1.39, I have this one, so 0.4177, 0.4177, and the answer would be 0.9177. So this is the probability. Or how can you find this area now by the calculator? Well, in the calculator, if you go to, again, the same process, number 5 distributions, you have number 3 R off. So number 3 will give you the right, okay, right. So if you write R of number 3, and then you write negative 1.39 inside it, the answer will be in the calculator 0.91774. And if you approximate to 4 decimal places, so you will get the same answer, 0.9177. The mean amount spent by a family of four on food per month is $500. So this is the mean. With a standard deviation 75. Assuming that the food costs are normally distributed. So mu, the mean is 500 and the standard deviation is 75. Well, family of 4 here, 4 doesn't mean anything. It means we are talking about population of families of 4 persons, okay? Assuming that the food costs, what is the probability that a family spends less than? So the cost spent, the cost follows a normal distribution. So if you call the cost X, so he's asking about probability of X less than $410 per month. So you change it to Z easily using the Z score. So 410 minus 500 over 75. And if you use the calculator, this will give you negative 1.2. And you can find this either by finding 0.5, as we mentioned, minus probability that Z is between these two numbers, okay? So you go to table, you look to 1.2, 0.3849, 0.3849. And if you use the calculator, the answer is 0.1151, or to find the probability to the left, you just use in the calculator P of negative 1.2. And the calculator will say 0.11507. When you approximate, you get the same answer to 4 decimal places. A goat farm has been feeding a special food to goats. A sample of the weights of 30 goats, so this is the sample size n, revealed that the mean weight, so this is the sample mean, and the standard deviation S of the sample. What is the probability that the mean weight for a sample? So the mean weight for a sample, this is X bar, of 30 goats, okay, exceeds greater than 41.5. So N again is 30. Well, to find the probability that X bar is greater, we change X bar to Z. But can we do that? He did not say that the population is normal, but N is 30. And when N is greater than or equal to 30, so using a central limit theorem, we can change X bar to Z. Z is X bar minus mu over sigma, which is sigma over square root of n. But we do not have mu here in the question. We have this X bar. So it's an approximation of mu. It is the best estimate of mu, so I use it. And also 3.8 is the best estimate of sigma, okay, over square root of n, which is 30. And X bar here, the one I need to change, is 40. Let me write X bar. So here, okay, I say this is equal to probability that Z is greater than 41.5 minus 40.27 over 38 over square root of 30. And if I use the calculator, this will give me, and round to 2 decimal places, this would be probability of Z greater than 1.77. Okay, and if you go to the table, how to find probability of greater than 0.5 minus probability that Z is between 0 and 1.77. And if you go to 1.77, this is 1.7, but I need now this one. So 0.4616. 0.4616, and the answer would be 0.0384. Okay, or if you want, you can ask the calculator, this is to the right, to find R of 1.77. And if you ask the calculator, shift stat distributions number 3, 1.77, the answer is 0.038364. If you round to 4 decimal places, this 3 will be changed to 4. A corporation has 11 manufacturing plants. Of these, 7 are domestic and 4 are located outside the United States. So those 11 are divided into 4 outside, 7 domestic, and 4 outside. All right. Each year, a performance evaluation is conducted for 4 randomly selected plants. So we need to select 4 out of 11. What is the probability that a performance evaluation will include exactly 1 plant outside? So probability of 1 outside would be, I have C, again, hypergeometric distribution. I have 11, and I'm going to choose how many? 4 randomly okay, for a performance is conducted for 4 randomly selected plants. And those 11 are divided into 7 domestic and 4 outside. And we need the probability that exactly 1 outside. So 1 from the outside, I need to choose 4. So 3 would be from the domestic. And you put it in the calculator and find the answer. The answer would be 14/33, or if you write it as a decimal, 0.424. The mean weight of trucks traveling on the MAM road is not known. Okay, so mu is not known. A state highway inspector needs an estimate of the mean. We need to estimate the mean. He selects a random sample of 49 trucks passing the weighing station and finds the mean is, so this is the mean of the sample. The population standard deviation is known. What is the 95% interval for the population mean? Okay, we have seen that the definition is x bar plus or minus 95%, again the number 1.96 from the T table times sigma over square root of n. So 15.8 plus or minus 1.96 times 3.8 over square root of 49, which is 7. So this will give you 15.8 plus or minus, if I multiply 1.96 times 3.8 over 7, I get 1.064. So mu will belong to the interval 15.8 minus 1.064, which is 14.736, and 15.8 plus this number, and this is 16.864. This is a discrete probability distribution and calculate the standard deviation. Well, we know that the standard deviation has this formula. Standard deviation for this distribution is square root of summation x minus mu squared times the probability of each x. Okay, this is the definition. So if you want to use the table, you need to find x times px, multiply these two, and then here you will have mu, okay, the sum, and then you find x minus mu, subtract 3 minus the answer mu. If you find mu is summation x px, I can just find it by adding. So 3 times 0.13 plus up to 12 times 0.6. If you put it in the calculator, this is 9.66. And then you find here 3 minus 9.66 and so on. And then you raise it to the power 2. And then you multiply the answer by the probability, okay? And the addition here will be sigma square. You take the square root, you get sigma. This is if you want to use the table. If not, I can just say this is equal to square root of x, which is 3, minus 9.66, which is mu, to the power 2, times the probability, which is 0.13, plus the second number is 6, minus 9.66 squared, times the probability, which is 0.12, plus the third number is 9 minus 9.66. So this is just negative 0.66 squared times 0.15, and then plus 12 minus 9.66 squared times the probability, which is 0.6. And you put it in the calculator and you find the answer. You will find that this is 10.7244. This is the answer you will get here. So this is 10.7244, and then sigma would be the square root of this, which is 3.2746. You can evaluate this actually using the calculator if you like. You go to shift mode, okay, first shift mode, and then go down with the cursor to number 4 stats, and you press number 4 and you choose frequency on or off, you choose on. This is the first thing. And then you go to mode stat 3, you need the frequency to be on, and then press 1 variance. And now the frequency is on, so write the values of x3, then 6, then 9, then 12, and then go to the frequency and press down below. It will take you up. So now write the probability instead of the frequency. So instead of frequency of 3, write the probability, which is 0.13. So the frequency of 3 would be 0.13. The frequency of 6 would be 0.12. The frequency of 9 would be 0.15. And the frequency of 12 would be 0.6. And then press on and go to shift 1, which is stat, and ask for 4, the variance. If you need x bar, okay, if you need mu, just press number 2. Say equal, you will find that the answer is 9.66. Or if you want the standard deviation, check number 3, because it is a population, sigma x, check sigma, not s here. The answer would be 3.274 as we have. A manufacturer of headache medicine claims it's effective within a few minutes. A group of 25 patients are given the medicine, and 8 patients experienced relief within a few minutes. So group of 25, this is N, and X, the number of people under consideration or success is 8, okay, within a few minutes. Construct 90% confidence interval for the population proportion. Good. For the population proportion, confidence interval is, as we mentioned, P bar plus or minus Z times square root of P bar. This is the formula, 1 minus P bar, which is the sample proportion over N. And to find Z, it is 95% confidence interval. So if you go to the T table, and this is the 90% confidence interval, go down, you will find that the number is 1.645. Okay, so Z here, so here P bar is what? 8 over 25, and 8 over 25 is 0.32, and Z is 1.645. So this would be equal to P bar is 0.32 plus or minus 1.645 times 0.32 times 1 minus 0.32, that's 0.68 over N, which is 25. And the answer would be 0.32 plus or minus, the standard error would be 1.645 times square root of 0.32 times 0.68 over 25, and the answer is 0.15347. So I'll just take 1.5. If you want to take 3, it's okay. So P will be in the interval 0.32 minus 0.15, and that's 0.17. And 0.32 plus 0.15, and that's 0.47. So this is the confidence interval for P. A company is studying in the number of daily debit card purchases and cash purchases. So we have two kinds of purchases, cash and debit. If the probability of a debit card is 0.4, if I call this D and this is C, so probability of D is 0.4. Since we have only two types, so probability of cash would be 1 minus 0.4, which is 0.6. What is the probability that 8 out of 15 purchases are cash purchases? So we can say here that we have a binomial distribution, and the number of purchases are 15 and 8 out, so this is X. So he's asking about probability of 8. And the formula for binomial, N is 15, 8, NC, 15C8 times P. Now P is the probability of success. What is the success here? Cash. So 0.6 is the success. This is the probability of success to the power 8, and 0.4 probability of failure here. 15 minus 8 is 7, and you just put this in the calculator, and the answer is 0.177. Thank you very much. I hope you enjoyed going through this final exam. See you in